Okay, so starting. So could you join that if you want to? So I'll send out an invite there to Zoom meeting. So yesterday we finishing on functional interfaces for so these are functional interfaces for primitive doubles, primitive ints, and primitive longs. Okay, so the first one we did was supplier. So the data type is called double supplier for primitive, a supplier for primitive doubles, in supplier for ints, long supplier for primitive longs. Now, what's a supplier? Normal supplier is it takes nothing, it returns an object. Okay, and if you don't supply it with the type, it's going to return object. Here, it returns a double. Now, a double supplier is something that takes nothing and returns a primitive double. Okay, now it returns a primitive double. Now the method for the double supplier interface is get as double. Okay, so a supplier for a primitive double, it's its own data type. It's called a double supplier. And what that does is it takes in nothing, it returns a primitive double. An int supplier, it's a supplier for ints that takes in nothing and returns a primitive int. The method in the only method inside the only abstract method inside the int supplier interface is called get as int. Okay, so we have supplier. And then we have consumers for doubles, primitive doubles, ints, and primitive longs. They're called double consumers, int consumers, long consumers. Okay. Now also, sorry, when you're doing a double supplier, you don't have to define a data type because it always returns a primitive double. And anyway, you can't define a data type of primitive double because data types can only be objects. Okay. So we have a consumer. Now, what does a normal consumer does? A normal consumer takes an object and returns void. Now, so in this case, a double consumer takes a primitive double. An int consumer takes an int and returns nothing. A long consumer takes a primitive long and returns nothing. Hi, Visa. Okay. So here we have double consumer. We don't have to define a data type because it takes a primitive double and returns void. Okay, so it takes in D and all it does is prints off D, so it returns void. So just like in an ordinary consumer, you can use the double colon notation, system.out.println. It always takes, it knows that double consumer always takes out a double. So what does this do? It just prints off the double. And the method of the consumer, of the double consumer class, of the int consumer class, and of the long consumer class is accept. Okay. And then I did an int consumer, and as well here, I just did a recap on what we can and cannot access inside of a functional interface. Now, if it's a local variable, you can only access variables that are final or effectively final. Effectively final means is if you have a variable, you can put final in front of it, it won't cause a compilation error. Okay? So effectively final is a variable that when you give it a value, you don't change the value. Leave this in there. Okay, so can you see the full screen there as a matter of interest? Can you see the full screen on your own screen there? Can you see me, in other words? And you can only see half me when I do that, yeah? No, okay. Okay, make a difference. Anyway, so I have a local variable, hi Jason, a local variable called null here. And so I can access that variable inside here. Let me just see. Right. So I have a variable called local int. All right. Now I can access local int inside here because I didn't change it. All right. Now I have another variable here called change int. I give it a value here 45. I don't change it until after the lambda. However, as soon as you change a local variable, that means it's no longer effectively final. So we can see we can access local int, no problem. This is the morning rules. So, however, change int we can't access. Why? Because I've changed the value. Okay, so you can only access local variables that are final or effectively final. Okay, now you can access variables of non-local variables, which are variables of the class. So for instance, weight, which was a static variable, and 1, 2, 3, you can access those and you can change them. Okay, so local variables are the only ones that functional interfaces have a problem, and they can only access them if they're final or effectively final. All right, so every other variable you can access them depending on same rules. If you're inside a static method, you can't access a non-static variable directly. It has to be a static variable, and we're inside public static void main. That's why we can't access. I have a variable down here, I think. What do they call it? Age. Okay. Anyway, so this is an int consumer, double consumer. Okay. Then we have double predicate, int predicate, long predicate. So what is a predicate? A predicate takes an object and returns a Boolean, whereas a double predicate takes a primitive double and returns a Boolean. An int predicate takes an int and returns a Boolean. A long predicate takes a primitive long and returns a Boolean. So again, you don't have to define a data type. Okay, so again, so we can see here, double predicate, double pred D, that's going to be our number that it takes in, which is going to be a double, and it's going to check, is D greater than 0.5? It'll return true if it is greater than 0.5, false if it isn't greater than 0.5. Okay, and the method of the predicate is test. So I go double dnum math.random, or print off the number, and then we have double pred, which is the name of our predicate, test dnum. The last one we did then yesterday was function. Okay, so what is a function? A function takes in an object and returns an object. All right, now, so a double function takes a cheeky. Double function takes a double and returns an object. Okay, int function takes an int and returns an object. Long function takes a long and returns an object. Okay, so double function takes in a double, returns an object. Int function takes in an int, returns an object. Long function takes in a long and returns an object. So yeah, yeah, these are all functional interfaces for primitives. Okay, now, so that means if it returns an object, that means we should supply it with a data type. Okay, so here the double function is the data type. So this returns an int. So it takes in a double and it returns an int. So D is a double, and then we multiply the double by 2, and we cast it to be of type int. Okay, this one here, int function. It takes in an int and it returns a string. So I is an int, and it returns I plus an empty string. That's all going to be a string. Okay. If you use the plus operator with the string, it concatenates the two of them. The whole lot of it becomes a string. Okay. Here I have a double function and it returns a string builder object. Okay, so takes in a double and it creates a string builder object from the double that was passed to it. And the method of the double function, int function, and long function is called apply. So what I did here, double func apply 2.34 get class.get simple name. Run that, see what it produces. So that produces a string builder. So that's to prove that this method here is producing a string builder. Yes? Okay. Now, so there's only 3 or 4 more than we have to do, and then we have this section finished. So that's the double function. Now, the next one is, actually these are the 2 last ones. So this is double unary operator, int unary operator, long unary operator. Now, so this is, what are these guys? This lad is the primitive equivalent of unary operation for ints, primitive doubles, and primitive longs. Okay, so what does the unary operator, ordinary unary operator, takes in an object and returns object of same type. Now, what the double unary operator does takes in a primitive double, returns primitive double. The int unary operator takes in a int and returns an int. And the long unary operator takes in a long, primitive long, and returns a long. Okay, so simple unary operator would be this guy. We would be double unary operator. Now we don't have to provide it with the data type. WN is equal to, so it takes in a double and just multiplies it by 2. Okay, and I need to go to here, import double unary operator, and the method for this is, it is going to be double UN dot apply as double 4.5. So that should return 9.0. Okay, int unary operator, similar. And it's going to be int UN is equal to I is going to be I multiplied by 10. So this one here is going to be int un dot apply as int 123. There we are. Okay, nothing too complicated about that at all. Now, the last one we do is the here. So this is the double binary operator, int binary operator, and the long binary operator. Okay, so what does the binary operator do? So ordinary binary operator takes in two objects and returns two objects. Okay, so the double binary operator takes in two primitive doubles, returns a double, primitive double. Int binary operator takes in two ints and returns a int, and long binary operator takes in a primitive long and returns a primitive long. Sorry? Yeah. Yeah. No. You can't return two. Oh, sorry. Which one? 601. So one. Takes into, I'm returning one object. Sorry. You can't return two objects. You can return an array, you can return a list, but you can't return two objects. Okay. So thanks for finding it out. Okay. So we're going to do a simple double binary operator. Binary operator. So double binary. And I'll import that. So it's equal to, we take in two numbers, D1, D2, and we multiply the two numbers, D1 multiplied by D2. Okay. And I'm going to do an int binary operator. And int binary is equal to I1, I2, and this is going to be I1 plus I2. And so I'll go to this guy here, import int binary operator, and then the method for this is called, again, is apply. So we go print off, double bind r dot apply as double. I'm going to pass it in two doubles, 2.3, and we're going to say 4.56. This one here, This is int binary dot apply as int, and we pass it in two ints, 1, 2, 3, multiplied by 4, 5, 6. Okay, now there is no, so that there's one's missing here. One seems to be missing. So there is, as far as I know, and if there are, they're not in the exam, so I don't give a shit about them. So there is no, I have it here. There is no by function equivalent for double, for primitive doubles, ints, and primitive longs. There is no by predicate equivalent for primitive doubles, ints, or primitive longs. And there's no by function equivalent for primitive doubles, ints, or primitive longs. Now, as far as I know, there's, okay, so now there is a, so the ones that are available for primitives are supplier, okay, consumer, predicate, function, unary operator, and binary operator. So it's, so there is no by predicate, there is no by consumer, and there is no by function. So the only, so any of the methods that take two things, by function, by predicate, or by function, there is no primitive equivalent for this. Now there is a binary. Binary is the only one. Okay, I'll go through them again. So our 9, I write out our 9 function interfaces. No by function equivalent for primitive doubles, ints, and primitive longs. No by predicate. Oh, so the last one's not by function. It's by consumer. Sorry. Yeah, by consumer. So I should say no by consumer. Okay. So our function interfaces are, okay. Come on. Set up. Now, so just to recap, what are the, so we have a supplier, we have a consumer, we have a by consumer, we have a predicate, we have a by predicate, we have a function, we have a by function, we have a binary, and we have a unary. Now, which ones? So they're all the function interfaces for objects. Okay, I am, Nikki. So the ones that exist, so is there a primitive equivalent? There's a primitive equivalent for supplier. There's a primitive equivalent for consumer. There's a prevalent, so not this guy. Okay, there's a primitive equivalent for predicate, not this guy. There's a primitive equivalent for function, not this guy. There is a primitive equivalent for binary. There is a primitive equivalent for unary. Is that okay? All right. So that is all of now. So as far as I know, there is no buy consumer for primitives. As far as I know, there is no buy predicates for primitives. As far as I know, there is no buy function for primitives. Now, there quite possibly, maybe there is. I don't know, but it wasn't anywhere I looked, and it wasn't in the book. So if it's not in the book, it's not in the exam. So guess what? We're not going to do it because we've enough to be frigging doing. Okay. Now, we're still not finished with streams. So as I said, there is an awful lot in streams. All right. So now this is this particular section finished. So this is the last section in this chapter. So the last section in this chapter, it's a bit of a mouthful of a name. So the name is, this is section 4.6. And it's called Working with Advanced Stream Pipeline. Concepts. Jesus Christ. Really rolls off the tongue, doesn't it? So working with advanced stream pipeline concept. Now, a stream pipeline is just your start, your intermediate, and your terminal. Okay, that's a stream. So a stream pipeline is just a full stream. That's all a stream pipeline is. All right. Why the dish don't call it a stream, I don't know, but so I'm going to create that class. So new Java project. So this is F4.6. Oh, I better upload this code as well. So sorry, this is working with primitives. I'll export this code. So work on primitives, finish. Right, so that's that exported. Now this is new Java project. If this is 4.6, working with advanced stream pipeline concepts. Okay, and it's fairly simple inside it. It's just got 4 classes inside it. The 4 classes inside it are cat, dog, examples, and main. Okay, let's put in those 4 classes, please. So new class, cat, finish. New class, dog, new class examples, and new class main. Okay, so we'll just do a small little bit of housekeeping. So go to the dog class, and in the dog class, we're going to say int age, string name. I'm going to go dog, int age, string name, and this dot age is equal to age, this dot name is equal to name. And I'm going to put a little print statement inside here to say dog created. Yeah. They can be, yeah. They can. If you create a stream, now you can only create, so they can have access modifiers. So let's say if I go up here and I go stream integer, my stream. Okay. All right. They can be private or public or whatever. You can't use an access modifier inside a method or inside a constructor. Okay. Inside curly brackets, you can't use. But yes, now I haven't been using streams of variables of a class, but you can. Nothing stopping you from doing that. Okay. So to answer your question, yes. Okay. So streams are just another data type. Okay. So a class can have as one of its attributes a string, which can be private, public, protected, or final. Okay. What other modifiers are there? Private, public, protected, or there's another one. Huh? No, well, you can't use default. Synchronized. Yeah, there are other ones as well. Okay, yeah, so it can't be synchronized. Variable can't be synchronized. Okay. Right. Now, we're not going to be using that string. But yes, a string can be an attribute of a class, a variable of a class. Nothing stop. It can also be static. Okay. Final, protected, final, or static. Okay. So there's nothing stopping you from doing a stream there. Yeah. And you can have your stream and initializer. So I'd say my stream is equal to stream dot iterate, start off with 1, and it's going to take in a number, and it's going to return that number multiplied by 2. I'm going to limit it to 10. Okay, so there you have a stream limited to 10. Okay, now just a quick question. Right. Now, when I run this code, what if I create a dog? All right. I quickly create a dog. Okay. I quickly create a dog. I quickly create a dog. Okay, so back here in examples. Right, so I go dog spot is equal to new dog, and this is going to be, the constructor is going to take an age and a name. So we're going to say 2, and his name is going to be Spot. Okay, so let's write this down here. All right, now, so I'm going to go back to here. Now, so initialize is run before a constructor, yeah? Okay, right. So when I create my dog, what's going to print out? Remember that initializers run before constructors. Huh? So it's going to print off the stream. Yeah, you see, the thing is, nothing's going to happen there. No, because I have no terminal operation. Okay, so it is going to print off dog created, but it's not going to print off our 10 numbers, just to prove that it doesn't. Wrong fucking one I'm running. Let's go to main. Dog created. Okay, because it's what we call lazy instantiation. Okay, it's lazy instantiation, and this will not run until there's a terminal operation somewhere. Okay, so if we put a terminal operation down here inside the constructor, okay, so my stream dot for each, and I'm going to put in a slightly longer, hold on, take off everything. So takes in a consumer. So I'm going to take in the int, and it's going to go all right. So so that guy plus that guy. Right. So it only runs after the dog is created. Okay, so this is lazy instantiation. So this here, this code does not run until a terminal operation is called on the stream. Now that can be anywhere. Okay, let's take it out of the constructor. All right. No, well, it's the same rules again, Priya. You can't access that stream outside of this class. If it's a static method, you can only access it directly inside static methods. Okay, so I'm going to change it from static to be that guy. Okay, now stream doesn't run. All right. So how do I get the stream to run? So what you can do, so this is called lazy instantiation. If you remember the singletons, we had lazy instantiation of a singleton. All right. So you have your code there to create the singleton, but you don't call the code to create the singleton until you need it. Streams operate the same way. Okay, this is called lazy instantiation. So the stream of 10 numbers will not be created until terminal operation is called on this stream. Now, it's not called inside the constructor. So what we can do is, let's say we have a method called for a dog. What does a dog do? A dog barks. And inside the bark method, so I'm just going to put in here, the bark method calls terminal operation on the dog's stream. Okay, so I'm going to call a terminal operation on this stream. Now I'm going to go my stream dot. I'm going to filter it out to only have, so it takes in a number, and we're only going to have even numbers. And then I'm going to call up a terminal operation, just prints them out. Now I'm going to make this terminal operation a bit longer than normal. So I'm going to say number is plus. So it takes a consumer, sorry. Right. Now, so the stream will only create the 10 numbers if I call the bark method. All right. Now that's different. Previously, if we wanted to create a list of 10 numbers, we create the list of 10 numbers when we create the dog. Okay. What this allows you to do is, this allows you to have a statement that will create the list as you need it. Okay. You could have objects. Let's say, for instance, you have an object that you have a person. They may own 10 pairs of shoes. They may own 50 pairs of shoes. They may own no pairs of shoes. All right. For instance. All right. I'll show you what I mean. Now, this is actually EX1 anyway. It's just another way of doing it. This is lazy instantiation. Right. I'm going to create a human. All right. Now, I am going to create class shoe. Shoes. Okay. Now, what variables does a shoe have? Int size, and we'll say going to have an enum called color, and we're going to have blue, black, brown, white, blue, black, brown, white, red, green. Okay. And we're going to have here, we're going to have a constructor. So it's going to be shoe. It's going to take int size, color. I don't have any enum here, so sorry. Color. It should be capital C. I call it shoe color. Okay. So we go. We have color, shoe color. What's on there? Give me a second. Why is it asking me for a return type there on the constructor? Have I done something wrong there? No, it's shoes. Fuck. Right. So this size is equal size, this color, this shoe color is equal to shoe color. Right. So I am going to have, a human is going to have a name. It's going to have an age. Now, he's going to have a stream of shoes. Stream shoes, and I'm going to say my shoes. I need to import that. Now, rather than putting it on all the code for the stream, I'm going to put it in and initialize it. Okay? Now, so my shoes is equal to stream dot generate. So I want to generate shoes of all the same size. Frigate, I don't care. So it takes a supplier. So that means it takes nothing. And it's going to take a new shoes. So the size is going to be int. So cast in int math.random multiplied by 10. Okay, so you're going to have shoes that go in size from, now I know that's wrong because everyone's going to have the same, you're not going to have different size shoes. Yes? Yeah. But we'll leave it that for now. Okay. So new shoes math int math.random is the first argument. And then I am going to go you go color dot, how the fuck do I guess color in here? Give me a second here now. Right, so I put enum as a separate class entirely. Okay, and so here I go color dot black. Okay, stream.generate and new shoes.
Owner of a black Peugeot 100706SO3015, contact reception. That's a black Peugeot 06SO3015. Thank you.
Right, so it's going to create a infinite amount of shoes that's going to have sizes between 0 and 1. Okay, I don't want them between 0 and 1 or between 0 and 10. I want them between 1 and 10. Okay, now color is black. I want to filter them to only shoe sizes that are going to be bigger than, so I'll put this all over a couple of lines. So I'm going to filter them to only shoe sizes greater than 7. Okay, so filter takes in a shoe. That's S. And I'm going to say S dot size is greater than 7. Okay, and I'm going to limit it to, now here's the thing, I'm going to limit it to 5. Now what that does is that creates a stream of shoes. Okay, going to be random sizes, but they're all going to be black.
If it is 777 means you want to distinct, you want to put distinct.
Say that again now, Priya?
Distinct.
Yeah, they're all going to be set. I don't care. Some shoes, yeah, I don't want distinct. Okay, so I don't want distinct. Okay. Right. You can create a stream of colors. Okay, so you can create a stream from an enum. Okay, forget how to do it, but we will do it. So what you do is you'd create a stream of those guys and it'll go through each one of them. So it'll pick black, blue, brown, red, white, green. Or do you remember you can go if I go color dot value of, you could do some sort of looping structure that goes through all of them.
I was going to say using the ordinal.
Yeah. Color dot ordinal, isn't it?
Yeah.
No, that's not a mistake.
There's something you can do with the ordinal.
Yeah, I forget how to do it. Jesus Christ, we'll have to figure that out again. Oh fuck, there's so much to remember. Okay, so you could use an ordinal there, but we'll just keep it simple. Okay. Now, so this generates 10 shoes. They're all black, and they're all going to be greater than size 7. Okay. Now, not every human is going to have shoes. Okay. If you're living in the Caribbean, you're on the beach, you don't need shoes. Oh, heaven. Okay. So, we're going to have a constructor that takes in a age and takes in a name. Okay. Now, I'm not going to take in a stream of shoes. Okay. Or what I'm going to take in is right. So I'm going to create a new variable here, and I'm going to call it shoe amount. Okay. And I'm going to go here. We go shoe amount. Okay. Now, So for limit here, I can put in shoe amount. Okay, so this human is going to be this dot age is equal to age, this dot name is equal to name, this dot shoe amount is equal to shoe amount. Now, if I send in 0, he has no shoes. Okay. If I send in 1, then it's going to generate 2 shoes. No, but it's not generated here in the constructor. All right. It's not generated here in the constructor. We're going to have a separate method called void make shoes. Now it's only at this point when I call this method that do we go my shoes dot for each, and I'm going to print off shoes. So I'll have a toString method inside here, inside the shoe class. So I'm going to go, it takes in a shoe. And it prints off all the details to do with the shoe. And we go up this slide here. Right. Now, so let me get an error there. So that guy, that guy. No. So bracket opens, one bracket. Okay, can I see what I've done wrong there?
No, I have a regular system.
Yeah. Oh no, shit, sure, I had this fucking thing here. Okay, right. Now, so the shoes are only going to be created if you call this method. Okay, shoes are going to be created if I call this method. All right, so I am going to see, I'm going to create a human here in examples. Okay, so I'm going to say human, my human is equal to new human. Now, what's the human take? Human takes a age, a name, and the amount of shoes. So his age, person's age is 24. Their name is Helen, and Helen has got 2 shoes. So if I go here, I go my human dot make shoes. We should see 2 shoes, 2 pairs of shoes being created. Okay, fingers crossed. All right. Now, I think I know what I've done wrong here. Right, here's the problem. Right, so when I do this, string name, int age, int shoe amount, okay? Now, initializers come before constructors, yes? So this code runs before this code, okay? Now, when that code runs, the amount of shoe amount is going to be 0, okay? Now, so that runs first, then the constructor runs. Shoe amount is 2, but the shoe amount here is still 0. So when I call the terminal operation on that guy, what it's doing is it's printing off 0 shoes. Okay, so if you have a variable like that there, it's not going to work. Okay, so what you need to do is the following. Okay, how would we fix that? How would we fix that? How would you fix that to such a way that I'm going to pass in 4 pairs of shoes and then it's going to create 4 pairs of shoes? How would I fix that? Exactly. Exactly. That's exactly what we'll do. Okay. So I go down here. Because remember, that's an intermediate operation, so you can do it. So now that should create us 2 shoes. Okay. Says I, hopefully. Yeah. Okay. Now that is lazy instantiation. Okay. You're only creating, so this guy here has the potential to create an infinite amount of streams of shoes that are going to be greater than size 7. Okay, it's only when I call the make shoes method that the shoes are actually created. Okay, so I'll say that again, put it in here. This is lazy instantiation. Our shoes are not created until we call the terminal operation in this method. So before, we'd have to create a list that could hold shoes. Okay, and it might be populated, it might not be populated. So you could just have an array list that's sitting there doing nothing. It's never used. So what streams allow you to do is it allows you to create objects as you need them. Okay, so here you have all the code to create your shoes, and it can be as complex as you want it to be. You want them to get pick different colored shoes, well then you'd have to do some form of ordinal or something like that. Okay, now I need to get back to ordinals because I'm after forgetting them, so I'll have to figure out that again. Okay, so it can be, you can have a method in there that gets you a color. You can have a method in here that only gets you size shoes greater than 7. Okay, or you can go filter size is greater than 7, and I can go filter s dot size is less than 9. So what's that going to do? All of our shoes are going to be size 8. Okay, now you can try to prick around with range clothes or whatever sort of shit, but that will ensure that all our shoe sizes are going to be size 8. Okay, so
Maybe he wants to sort of build a pattern.
funny you should say that. Okay, because when we come to threads, okay, you use streams in combination with the builder pattern. Okay, yes, you can use builder patterns and streams. Okay, so yes, you most certainly can. Okay, so you can put in as many filters as you want. Filters are very handy. Now, you could put in a filter that says size is greater than 7 and size is less than 9, but I don't like using n's and r's. All right, I personally think that's easier to read. All right, so that's going to be shoes that are greater than size 7, shoes that are going to be smaller than size 9, which is going to be 8.
Currently, that can only fire once you run the terminal. be unaccounted.
Yeah.
Yeah. So is there a way of changing that?
You need to be careful doing that, of course. Yeah. So if I went to, so if I called make shoes again,
Or if that should fall over?
it's going to fall over. All right. So now what you need to do is that, here's how would you get around that? I don't want to change this, by the way. How would I change that? So that each time make shoes, right, what you do is you'd create a set of shoes. Okay. And this is going to be shoe set. Now, down here, what you would do is you would go, you would change this. Okay. I would say shoe set is equal to my shoes dot limit shoe amount dot collect. It is collect dot to set. Okay. So what does that do? What that does is that creates, we now have a shoe set of shoes. Okay. So that creates our shoes. And we can use that shoe set from that point onwards to create. Now we'd have to go messing around with a bit, right? So if I do that, I have our shoes, I have our set of shoes, our set of shoes created, yes? And then if you want to change it back to a stream, all you have to go is shoe set dot stream. So you'd have to put in some sort of if statement here at the top. If shoe set, so what you do is if shoe set dot is empty. So if it's empty, we do that. Okay. Otherwise, we do this. Shoe set and all of this. All of this dot collectors to set. Now that's not the most neat and tidy thing in the world, but that's basically what you're doing there. Okay, so if it's empty, if there's no shoe set in it, that means we call this guy here. If it isn't empty, we're going to create it all over again. That's what we're doing there. Okay, so this is here. Yeah, builder pattern will be a lot better than that. Okay, that's messy as fuck. Okay, so we have a set to hold all of the shoes created by the stream. If the set is empty, that means the stream has not yet had a terminal operation. Okay, so you can run the terminal operation on it. Right? If a terminal operation has been run on the stream, we recreate the stream. Okay, and that's going to create our shoes again. Now I need to change that here. So it's dot limit shoe AMT. Now you'd have to do other things just to make sure. Obviously, you should devise some sort of other method that takes care of all of this for you. Okay, so if you call that more than once, bollocks, and one pointer exception. Java 40. If shoe set is empty. I've done something wrong there. Okay, so do you know what? I am going to just take it out. Okay, so I'm just going to comment on all of this crack. Now, this is a typical example of you need to do your streams one operation at a time. I didn't there. All right, so there's something wrong with my logic there. All right, so I am just going to go that guy there. I print off my shoe set. And legal state exception, because I have it here twice. Okay, is that right? So I'm not going to change, where am I? This guy here, right? So that produces a shoe set of shoes. Simple as that, okay? So this person now has a shoe set of shoes. Yeah? Now the shoe set of shoes may have something in them or may not have something in them. All right? Yeah, okay? That is lazy instantiation, okay? So they're not created until we go make shoes. I'll have a look at that and we'll see how to get it working right. Is that okay? Okay, now, so that's EX1 done. Okay, so just see human class for lazy instantiation. Now, so the next one, static void EX2. Okay, so these are all now, so this is showing you an example of using optionals. Now, you can use functional programming with optionals. All right, now, they're not streams as such, but you can use functional programming with optionals. What do you mean by functional programming? You can call methods on it. Okay, you can call methods on it. So here's the problem. So we're going to create an optional. I'm going to call it opt-int. And it's going to be an optional. So this needs to be imported. That of 123. Okay. So we can use or else get, but here we're going to use an if statement. Okay. Hi, Andrew. So if opt int dot is present. So that returns true or false. I'm going to say opt int dot get. Now, so that will get you an option. Okay, that will get you an option. Now, let's say we want to check if a number is 3 digits, okay, or not, okay? So what we're trying to do here, so what's the problem we're trying to do? We are attempting to check if a number is 3 digits long. Now, you could say, yeah, if it's greater than 3 digits long, that's one way to do it. Okay. We are attempting to check if a number is 3 digits long. So we could say if a number is greater than 100, then it's going to be 3 digits long at least. Yes. So we're attempting to check if a number is 3 digits long. You could say it's greater than 100 and less than 1000. Okay. The thing is now, I'm not too sure how to get it displayed like this, but you can get that number. Right? That number is 3 digits long. Yes? So we're trying to find out what numbers are 3 digits long. It is possible to get that number. I don't know how to display it, but it is possible to get that number. Okay? Now, so we're attempting to check, is a number 3 characters long? Okay? So if we were just going to say all our numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 101, 102, all we'd have to do is get the numbers between 101 or between 100 and 999. Yes? It doesn't take into account those numbers. Those numbers do exist. Now it's still 1, but what we're trying to do is we're trying to get all of the numbers that have got 3 characters in them. Yes? So what we obviously have to do is we have to take the number and we have to change it into a string. And then we have to count the amount of characters in the string. And we want to get all the strings that have only got 3 characters in them. Yes? Right, so. Now, so we're going to try to accomplish this without streams. Okay? So, we are going to start off with a number. Okay? So, we are going to say opt-int, which is 1, 2, 3. Okay? So, first off, we start off with if opt-int dot is present. So, if there is a number there, because remember, optionals may or may not have a value. So, as we're going along here, we're going to be using max. There's something called max by, min by. These are all to do with collections. So, if opt-int is present, so what we do is we go integer num is equal to opt-int dot get. Now, so from that we're going to produce a string. So we're going to say string is equal to blank string plus num. All right. So now that creates, so our number was 1, 2, 3. It's now going to be the string 1, 2, 3. Yeah. So if here, if string dot length lowercase is equal to 3. I'm going to print off say string is 3 digits long. Else I'm going to say is not 3 digits long. Now, so what we're going to do instead, we're going to use functional program with an optional. All right. So you can use functional program with an optional. Now, they're not exactly streams, but they operate like streams. Okay. So most of the methods of the stream class are also available to options. Okay. Right. So most of the methods of the stream class are also available to options. Okay. I don't particularly know which ones are not available to us. But we're only going to be covering really the ones here that are available to us. So that ends there. End of if. Okay. So this one is using functional programming with optionals. Now, these are optional, those guys. Not the optional doubles, optional int, optional long. Okay? These are optional for objects. Okay? So, opt-int is an optional of type integer. Okay? And it is, so we go like this. So we start off with opt-int dot. So we can see all of these guys here. Okay? Now, it doesn't have all of the methods. For instance, it doesn't have generate or it doesn't have iterate because it wouldn't make sense to be generating an infinite stream of numbers from this guy. Okay? It also doesn't have iterate. But it does have, now the methods it does share with the stream class do the exact same thing. So if we want to change from one data type to another, we use map. Okay? So it takes something called a mapper, and all that is we're changing. So it takes in, what does it take in? It takes in an integer. And it's going to return, it can return the same type, but it's not going to return the same type. It's going to return a string. Okay. Next one is going to be dot filter. So we only want, so it takes in, filter takes in, so this is now string. Okay. So this is a optional of type integer. When we get to here, it's an optional of type string. Yes? Yes? Okay. Now, so filter takes in a string and it only takes in those that have the length that's going to be equal to 3. Okay. Now, the next one we're going to use is if present. Okay. Now I can only use if present at the end because if present returns void. Map returns an optional of type string. Filter returns an optional of type string. What optional of type string does it return? Only those strings that have a length of 3. Okay, so then I go if present, because it's still an optional. There still might be nothing in it. Okay, so if present takes consumer, so it takes in a string, and I'm going to put it over a few lines. So I'm going to say number in string format is plus s. And we want to see, is s a string or an integer? Let's see, s is a, I go s dot get class dot get simple name plus class. I'm going to run that guy. So I'm going to go back here to main. So we can see now that really isn't an awful lot shorter than this one up here. Okay, but all I'm showing you is that you can use functional programming, all right, which is stream-like programming for optionals. Okay, so you can use stream-like programming for optionals. All right, so this guy here, it changes our optional to a string. Then it filters them to 3. Now this does take, if your optional has nothing in it. So let's say if I go this should still work. All right, so even if it's empty, it'll still work. Okay, even though if it's empty, it'll still work. Take it out. S is a string class. Okay, so as we go down here, we're going to be doing, that's right. Yeah, as we go down along doing more of them, we're going to be using streams for streams. And we're also going to be using, so we're going to be using functional programming streams. That's how streams operate, functional programming. And we're also going to be using functional programming on options. Okay? You can't do that with integers. Let's say if I create an integer here. Integer num is equal to 23. And if I go num dot no map, no dot filter. Okay, so options allow you additional methods that you can use to modify them or to check to see, is this a correct string? Is this a correct dog? Is this a correct cat? Is this the correct amount of people in the class? And do each of those people in the class have the correct qualifications to do this course? Or check all the job applicants and do they all have the minimum qualifications? And then you can do a reduction on it to get the one qualified candidate for the job. All right. So, yeah. Yeah, well, you see, well, if present is just void, okay? So what you would put in here is whatever calculation you want to do on this number, you'd put inside here. Okay. Now it returns void. It doesn't return the value. Okay. The other methods of it are, let me just see. So you have filter, you have flat map, you have get, you have if present, is present, or else get, or else throw. So there isn't an awful lot of methods available to us, but the ones that are available to us is filter. That's the main one. Okay. And map. Isn't it? Yeah. Okay. So let me just be sure. Let's do this again. So we've got filter, we've got flat map, we've got map. Okay, they're the main ones. Now we're going to be doing flat map. Probably won't get to it today. It'll be tomorrow before we get to it. All right. So the main methods for options are map, flat map, and filter. Okay. A map allows you to change your data, your optional to another type. Okay. Filter allows you to check, is this person a fit candidate to be a trainer of a hurling team for under 12s. And you can have filter in there, you can have as many variables as you want. You can have a method that checks each individual person. Okay, so yeah, don't know what to say.
Just on line 20 here, just put line 50 here. So you gave the value 1, 2, 3, right?
Yep.
So I'll just if you let out if of print of ink is present, will it still work or will it not?
Oh, it'll work all right, but you see the danger is this. Okay, so it'll still work.
Yeah.
No problem. The problem is optionals can be this. Now, optionals, max is an optional, min is an optional, average is an optional. The reason min is an optional is because twofold. First thing, it could be you're doing your list, you're doing a stream that produces a stream of objects. Now, after you're doing all your checks, you might produce nothing. Okay? So a max of an empty stream is going to be nothing. A min of an empty stream is going to be nothing. An average of an empty stream is going to be nothing. Now, a sum of an empty stream, it depends what you're summing up. If it's a stream, if it's an int stream, then it's going to be 0. All right? So the whole idea of streams is you have a load of data there and you're operating on the data. You want to see what's produced at the end of it. There may be nothing produced at the end of it.
So even in that case, when you gave the value, just look up practice, you know,
Yeah. What you'd either say is present, if present, or else get, or else. Okay. So here I just decided to go if opt-int is present. Okay. Now, so just gonna go back here. So just to go over optionals again, okay? This is an example of options, okay? So I am going to create a list of integers. And I'm going to call it nums. And I'm going to go equal to stream dot generate. Let me just copy this whole fucking thing. collectors at to list. Why isn't it? Why is that giving me an error there? Collectors at to list. Why is that giving me an error? Hold on a second here now. Just give me a second. What have I done wrong there? Maybe I haven't. Right, that's possible because I'm not importing that. Just give me a second now. Right. Yeah, that's all it's on there. Okay, right. So this creates a list of numbers, a list of random numbers. They're all going to be distinct. I'm going to limit to the 5. We're going to print them off, and then it adds them to a collector list. Yes? Okay. So now, if I want to get the max of this, okay? So now it's different from the maxes for the in stream. This is using max for optional of type integer. Okay, so it's an optional of type integer. I'm going to go opt. I'm going to call this max. So it's equal to nums dot stream. So that creates our stream. So now we have a stream of numbers based on this guy. Yeah? Okay, so this has the potential to produce these 5 numbers. Okay, so nums.stream, it's based on this list of integers. So it's at this point, it's a stream. If I go dot max. Now max takes a comparator. A comparator is, it takes in 2 objects of the type, and it returns 0 if they're the same. It returns a plus number if the first number is bigger than the second number. It returns a minus number if the first number is smaller than the second number. So it takes in this case, 2 objects. The 2 objects are integers. So we go here, max. So it takes in 2 things. So it takes in number 1 and number 2. And it's quite simply this in 1 minus in 2. Now, how that works is, let's say we have, our numbers are going to be, let's say, 10, 25, 7, and 9. Okay. What it does is, it takes in these 2 numbers. It goes 10 minus 25. It sees that that produces a minus number. That produces minus 15. Okay? That means that this one is bigger than this one. So it marks 25 as being the temporary biggest one. Then it compares 25 with 7. So it's 25 minus 7. That gives us a plus number. That means that 25 is bigger than 7. So it goes on to number 9. It goes 25 minus 9. That gives us a plus number, which means 25 is bigger than 9. And that's the final number. So that marks off 25 as being the max number. That's how it works. Okay? Now, that produces an optional. Okay? Now, because, as I said, the stream could be doing all sorts of mad shit. Right? And it may produce an empty stream. Okay? It may just do that. That's what streams are good for. It's taking in a load of data. It's working through it. It's looking for a match. Let's say if you type into Google Or if you type in something, let's say you're looking for a match in Tinder, okay? You can't find a match. That's an example of an empty string, okay? So if your conditions are not met, you've loads of filters, limits, distinct, all sorts of things going on in there, all right? Any match, all match, if you remember those guys. All happening inside here. That may produce an empty string, okay? It may produce a list with nothing in it. So if I go nums, so if it nums has nothing in it, stream.max, it has to be able to return nothing. Does everyone understand why you need to have an optional? So then opt max, then to get the value. So how would you get opt max? So opt max just prints off optional 93. If you want to get the actual int value of it, opt max.get. However, if it has no value, it's going to give you a illegal. What does it get you again? So you get a no such element exception, okay? So no such element exception. So we can use opt max dot or else. That just return another integer, so return 0. Or we can use opt max or else get. So we would call our int supplier. So we go int math dot random multiply by 100. So that guy. Okay. And that gets us to lunch. Okay. So when we come back from lunch, we're going to be using functional programming with optionals, and we're going to go to something called collecting results. It's methods of the collector method. So I will stop